Hi guys, welcome back. Today we're going to be talking about organic reactions. So, we're going to be talking about substitution, addition, esterification, combustion, fermentation, and saponification. Now, I have mine on a PDF, but yours is breaking down into a Google Doc. Really simple. You're not going to be doing the exercises. You're just going to be um analyzing the reactions and basically describing what's happening, right? So for model one is talking about substitution. And the first question, as we can see here, we have an ethane, which is part of the alkane group, hydrocarbon. Which is part of the alkane group. And then we have chlorine. And once again, chlorine is one of those diatomic elements that cannot be by themselves. So we have chlorine coming in a pair. In the substitution reaction, so this is our reactants on this side, and this is our products. I know a couple of us are getting a little lazy with identifying what is our reactants and what is our product. Our reactants are always on the left side, so you must look at the elements on the left side, right? And then our products are always on the right side. We must look at the elements on the right side. And when I actually, don't tell me it's left or right. I know that. Let's be specific in our answers. So tell me ethane and chlorine are my reactants, and chloroethane and hydrogen chloride are my products. Okay, so what's happening in this reaction? As you can see right here, ethane is going to combine with chlorine. Now, when that happens, this H, this chlorine, sorry, I'm going to try to explain this in the correct mannerism. This chlorine is going to lose itself and jump onto this hydrogen is going to lose itself and jump onto this chlorine, while this chlorine over here bumps it out and replaces it. So literally what is happening, and we can see that over here where the chlorine has gone ahead and has replaced itself in the reaction. The chlorine has replaced a hydrogen in the reaction. So substitution reaction is just basically saying one of the reactants is going to replace one of the hydrogens in the hydrocarbon. Remember, this is no longer a hydrocarbon. This is no longer a hydrocarbon. So this is now, right, an organic compound. And if we look at table R, we would notice because it has this chlorine right here, it's a halide, right? So substitution reaction, one of our reactants goes ahead and replaces a hydrogen in the hydrocarbon. And that's it. So if I had to go ahead and do this exercise, which you don't have to do, but I just want to show you an example. This we have methane, which is one carbon, four hydrogens, and bromine. Once again, bromine is a diatomic element, so it cannot be by itself, so it always comes in pairs. This bromine is going to go ahead and replace hydrogen right here. And this hydrogen, not wanting to be left out, is going to go ahead and bond with this bromine right here. So that would create, let's see if I can get this right. Sorry about that. C, hydrogen, hydrogen, hydrogen. And then over here we would have Br. And then plus 2, our other product would be H, B, R. I'm using my PDF thing, so give me a second. There you go. So that's what's going to happen in a substitution reaction. All right? That is what happens in a substitution reaction. Now, when we have addition reaction, we're a tad bit different. How is an addition reaction? If we look over here, we have one butene. Because we have this double bond here, we are part of the alkene family. We have one butene plus chlorine, which is our reactant, and then we have 1,2-dichlorobutane. So, how are the reactants in this reaction similar to those in a substitution reaction? Well, as you can see over here, if you look at the product side, the chlorines have gone ahead and replaced the two hydrogens over here. So the chlorines have gone ahead and replaced two hydrogens. Now, that's the only way they're similar. What is actually happening, that's the only way that they're similar. The only reason that they're different is because over on the substitution reaction over here, we had an ethane, right? So we're dealing with an alkane. With addition reaction over here, we're dealing with usually something with multiple bonds. So it's an alkene or alkyne. And for the replacement to work, we're going to have to break this bond. So when we are adding chlorine here and we're adding chlorine over here, this can no longer be a double bond because carbon can only bond 4 times. So we're going to break this double bond and then we're going to add the chlorines there. When we have an addition reaction, by the time we have our product, we only have one compound in our product. We will not have two products like substitution. We will only have one product. And obviously, because we see two chlorines right here again, this is no longer a hydrocarbon, meaning it's no longer an alkane, alkene, alkyne. We have to look at table R to see what type of compound we've created. And this is a halide organic compound, just because we have the Cl's attached to our carbons here. So if I were to do this reaction, we have pentane plus hydrogen. Hydrogen, a diatomic element, cannot be by itself. We're going to have, I'm going to try to do this without any interruptions. We're going to have C, pent, that's 5, 1, wait, one more. All right, so this double bond right here, what's going to happen is these hydrogens are going to go over here and they're going to go over there and they're going to attach to these hydrogens, these carbons. So that means this double bond gets canceled out. And then they go ahead and attach. Remember, my dashed lines represent hydrogens. I don't want to write all my hydrogens out, so I create dashed lines to represent them. And all I need to remember is that my carbons can only bond 4 times, so they should only ever have 4 dashed lines going towards it. And this is what my compound would be. This would be a pentane instead of a pentene. Just an example. Now, combustion. We've done combustion reactions before. Combustion reactions, when we were talking about our inorganic compounds, we said we had synthesis, decomposition, single replacement, double replacement, and combustion. And we've actually seen that reaction happen in lab. So, in this combustion reaction, you will always have a hydrocarbon reacting with an oxygen. Those are our hydrocarbon is C3H8 and oxygen. These are our reactants, and our product will always be carbon dioxide and water. That is what you will always form. So what happens in the combustion reaction is that the oxygen provides fuel for the propane and literally causes a decomposition where the oxygen is shared amongst the carbon and the hydrogen. Obviously, this is not a balanced chemical equation. If it was, you would see how it was distributed properly. But what happens, I'm going to repeat that again. What happens in a combustion reaction, and I'll give you another example of how it looks like. What happens in a combustion reaction is that, once again, the propane, our hydrocarbon, is split up. So we split the hydrocarbon into carbon and hydrogen, which then reacts with the oxygen to produce carbon dioxide and water. This was the example when we had in, I want to say January, where we had Donnie going out with, I'm going to create new names. Donnie going out with Melissa and then going out on a date with Franny and then them meeting at the dance realizing they're dating at the same person, right? So they split up the friendship and then they produce 2 new compounds. Esterification. Now, the reason why I love esterification is because esterification produces perfumes. Anything that smells nice is an esterification reaction, or ester. It produces an ester. Obviously, esterification will produce an ester. So, if we look at what produces an ester, we'll notice that this has an organic acid functional group, right? So this is ethanoic acid. It has an organic acid plus propanol alcohol, which has the OH right here, right? So it takes an acid plus an alcohol to create an ester, which is right here, right? It takes an organic acid plus an alcohol to create an ester. Now this was something that I really wanted us to do in the class. Sadly, coronavirus did not allow us to do it, but when I did it in college, we created that winter fresh feeling that you get with spearmint gum and other like wintry scents. It's honestly one of the best experiments ever. I'm going to leave the reaction and go to fermentation. So when we have fermentation right here, let's focus on fermentation. Fermentation, we have sugar that's going to produce ethanol and carbon dioxide. Now, our sugar, as we know, is a organic compound, not a hydrocarbon, an organic compound. And for this reaction to actually happen, what you're going to need is yeast or zymes, and that is our catalyst. That is going to be our catalyst. Is what's going to force the reaction to happen a whole lot quicker. It's not going to change the reaction. It's just going to force it to happen a whole lot quicker. And when that happens, we produce alcohol. So this is how we get a lot of spirits. This is how we get vodka. This is how we get vodka. This is how we get a lot of major alcohols out there in the world, through fermentation. Right? Once again, the yeast and the zymes does not change the reaction. It just causes it to happen quicker. All right? And obviously, ethanol is an alcohol functional group. Now, my second to last one. Is this my second to last one? I think so. Yeah. So my last one happens to be saponification. And do not ever worry about knowing what the reaction is. Just knowing what the actual formula is. Just focus on the name, because I love the name. Saponification, right? So to create a saponification reaction, you need to have a fat. Fat just needs to be any type of fat. You need to have a fat and a strong base. And what you're going to essentially create is soap. So just like esterification produces esters, saponification produces soap. Right? So our reactants are fat and a strong base, and our products would be soap and glycerin. And this is how we get a lot of the major soaps out there. This is how we got a lot of soaps from Bath and Body, from Olay, from Irish Spring. It's all about fat and a strong base. And this was also another reaction that we were going to do in class. Sadly, we did not get to it. So, those are our 6 chemical reactions. I'm not going to focus on polymerization or the other one. I don't really think it's that important at this stage. But for you to be able to know organic chemistry at just a brief level, you need to know that these are the reactions that produce some of the functional groups. So these are the reactions that produce halides, alcohols, esters, ethers, organic acids. Did I say alcohol and halides, right? These are the reactions that produce those functional groups. So an addition reaction can produce an alcohol, or it can produce a halide. Organic acid and alcohol will produce an ester. These are those reactions. So go ahead, complete your notes for today, and if you have any questions, please feel free to ask. I'm here to assist you. We're almost done. Keep your head up, and I hope you have a great day, guys. See you around.